Hello? Testing. Okay, so I see that I have three people in here. I'm probably gonna wait till like 6:30, but if you want, you can text me your questions already, so I can start setting up and maybe put some problems on the screen for us to work it out. Hello, can you guys see me? Yes, hopefully you can. What you can do is, I'll put the number up on the screen again, but you can text that with questions. If you don't have any questions, what I'll start doing is I'll just start going through sections that students struggled with the most, and then you can ask me questions from there. But if you do have a question, or you think of something as we're going through this, just text the number and it comes up right on my screen. So I'll put that number up again. And I'm going to go ahead. It is 6:30, so I will get started. I'll probably start with section 4.4 because I think that's probably what gave students the most trouble. But if it didn't give you any trouble, text me a question and I will go over anything you want me to go over. Simplifying complex numbers, exactly. So I'm going to go ahead and go over that one first. So let me share my screen. Here we go. I'm going to share that. And we're going to start by simplifying some complex numbers. And that was section 4.4. So I'm going to put that up here so if anybody comes in, they know what we're going over. So section 4.4, and it was our complex numbers. So I'm going to start with probably what I think is the trickiest one when we're simplifying complex numbers. It's like a division problem. So let me pull one out. I'm going to pull one from the section. We'll go ahead and do a division problem because those tend to be the longest ones. And so we're going to go ahead and simplify 2 minus 4i over 1 plus 3i. So this is a division one, and we're going to be simplifying it. So let me write that up here. Simplify. Okay. So when we're simplifying specifically a division problem one, our goal is to get rid of the I down here. That's what we want to get rid of. So in order to do that, we have to multiply through by the conjugate, because when I'm doing division, I want to get rid of that I. So the conjugate, it's always going to change depending on the problem that we have. In this case, my denominator is 1 plus 3i. So the conjugate would be 1 minus 3i. There's my conjugate. And what I do to the bottom, I have to do to the top. So it's going to be 1 minus 3i on the top as well. Okay, so what happens when we do this is we're actually creating, this is a multiply, so I'm going to put an X there for multiply. We're actually creating two little multiplication problems. So I'll start with the bottom first, and all we're going to do with the bottom is multiply the bottom through. So you can FOIL the bottom, because they're exactly the same thing on the bottom. The only difference is my plus and my minus. That's the only difference. So all I have to do is multiply 1 times 1, which is 1. And then I would say 3i times negative 3i. Now I can only do that because they're exactly the same, but opposite signs. We won't be able to do that with the top. But the bottom I can say 1 times 1, so this guy times this guy, and then our back guys multiplied by each other. So that would be, that gives us negative 9i squared. Okay, and I'm completely going to ignore the top right now. All I'm going to do is work with the bottom. So then I have 1 minus, and I squared is just negative 1. So I'm going to replace my I squared with a negative 1. So now I have 1 minus 9 times negative 1, or negative 9 times negative 1. So really that gives me a positive 9. And then I have 10 on the bottom. So all I did was work with the bottom. But I have to do the top as well. So I'm going to be FOILing the top. I'm going to multiply 2 times 1. So that gives me 2. Then I'm going to multiply 2 times negative 3i. So there's my, that's going to give me negative 6i. Then I'm going to multiply negative 4i times 1. So that's going to give me negative 4i. And then my last one would be negative 4i times my negative 3i, so these two, which would give me positive 12i squared. Okay, so that was the trickiest part, was the multiply. From here on out, we're just going to be combining like terms. So I noticed that I have a 6i and a negative 4i, and those are like terms. So then I have, on the top, I'll have 2, negative 6i, negative 4i is negative 10i. I see a question, but here, let me finish this one up. So negative 10i and then plus 12i squared. And the question was, let me look at it. Does I equal 1 no matter what? I squared, let me write that up here. I squared is what gives me negative 1, not I. Okay? I does not give me negative 1. So this guy here that we have here, let me highlight him. He's not going to be changing to a 1. He's going to stay just like that. Only I squared do we change it, and it has to be negative 1. Don't change that I. So then what's going to happen then in our next step is, so now I have 2 minus 10i, and I can't combine those, but I do have an I squared, so that's what's going to change to my negative 1. So I'll have 12, I'm running out of space here, 12 times a negative 1. And then here, let me move this over a little bit. So what I have is, and I'll highlight it, I have a 2, which is a real number. And then I have 12 times a negative 1. Well, that's going to give me negative 12. So 2 minus 12 is going to give me negative 10 on the top, negative 10. And then minus my 10i. I can't combine my 10 and my 10i. So this one, we're pretty much done here. But we can do some simplifying. So before we can say I have my final answer, I need to make sure, can I simplify? And if you notice, all three of these guys, we have a 10, a 10, and a 10, can all be simplified by 10. So if I say 10 divided by 10, I get 1. And I'm going to do that 3 times. I'm going to write it here. So 10 divided by 10, that's going to simplify to a 1. This will simplify to a 1. And this will simplify to a 1. So really all I'm left with, I don't have to write the 1 on the bottom. So really all I'm left with is negative 1 minus I, or you can say 1i, however you want to think of it. And there's our final answer, and that's all simplified. Okay. Is there another type of I problem that you need help with? So really when we do division, we've covered the division and the multiplication. Because really, even though it looks like a division problem, it's really a multiplication problem. So is there any other ones you guys want me to go over for complex numbers? I will. So as I wait for another question to pop up, another area for simplify that I saw students struggle with is something here. All right, so it's the same direction, it's still simplify, but it's something that would look like, let's say, I to the 50th power. And you're asked to simplify that. That's another area that I saw students struggle with a lot. So when you are asked, okay, so that's kind of like I'm going to go over now. So we can do I to 55. So let me erase that. Let me erase 50. Let's put 55. So let's say we have I to 55. What we want to do to simplify these is to break this down. So in class, in your notes, you have, I believe you should have, what I equals, which I was just I. You have what I squared equals, which was negative 1. You'd had that I to the 3rd was equal to negative I. And then I to the 4th was equal to 1. So these are the really important ones. I is just I, so I'll just put that. And I'll put a box around these because this is what's going to help us simplify the bigger numbers. So all of our, when we're asked to simplify something to like I to the 55, all of our answers will end up either being I -1, -I, or 1. Okay, so that's the 4 options that you could always get. All your answers will always end up with those 4 options. So I to the 55. Notice how I to the 4th is 1. We like that because 1 is easy to work with. So what I'm going to do, okay. What I'm going to do is I'm going to go ahead and say I to the 4th, which is really just 1, but I'm just going to write it as I to the 4th right now. And I'm going to figure out how many times does 4 go into 55. Okay, so if I go ahead and say 55 divided by 4, it gives me 13.75. So that means it only goes in a total of 13 times. So I'm going to go ahead and say I to the 4th is, here it is, I to the 4th, we'll say 13. Exponent properties say that 4 times 13 is 54. So right now I need 55 i's. I have 54 i's because 4 times 13 is 54. So here's the last I. Here's the last I that I'm going to need. Okay. Well, we just said that I to the 4th is 1, which means that this entire thing is just equal to 1. That's what that means, which is why we want to work with I to the 4th. When we work with I to the 4th, it makes it nice and easy. All of that is just going to be 1. So then really all my final answer is I, because 1 times I is just going to leave you with I. So that would be your final answer. Okay. Those are 2 spots I found in 4-4 that students struggled with. And if you just joined us, you can text the number I sent it out in the message. Let's see if I still have the slide here. Nope, that's another problem. No, I don't have it. But here, I'll put the number up here. It is, I'll put it in red. If you want to ask a question, just send a text to 407. Oh, I got one. Am I going to give you charts for eyes? No, I would not be giving you a chart for eye. Because really all you need to know are these four eyes, the ones that are in blue. So I got the question, am I going to give you a chart? I will not be giving you a chart. All you need to know are these 4 right here. If you know those 4, you know all the answers already for any type of I to the 65 or 100 that I give you. So another area, I'll also add, you can keep asking questions, but I'll keep going over different concepts. So another place that you can use complex numbers is if I were to ask you to solve. So if I were to ask you to solve, let's say I said solve, and let's say I'm going to give you, I think of one. Correct. The whole problem would still be I, correct. Because I to the 4th is 1. And then 1 to the 13th is still 1. And then 1 times I is still I. So 1 to the 13th power it's just saying 1 times 1 times 1 times 1 times 1, 13 times, which is just going to still be 1. I hope that answers that, but if it doesn't, just keep asking. So we have x squared, let's say x squared, and let's say I say plus 49 equals 0, and I could ask you to solve this, okay? Well, a lot of you guys know how to do this, and if I just were to say solve, you could use any method that you wanted to. You could use a quadratic formula, you could use factoring, whatever you wanted to do. To use complex numbers, all you would do would be minus 49 on both sides, so that would cancel. So I would be left, that should be 49. So I would be left with x squared is equal to negative 49. We square root both sides because my final answer is just, all I want is an x. Okay, so when I do that, I get that x is equal to, and here's a part that students mess up a lot with. Whenever I give a square root, you have to put a plus or minus in front. Now the square root of 49 is just 7, and that still hasn't changed. But because we have a negative 49 under that square root, our final answer would be 7i, because technically in real numbers we cannot have a negative under the square root, but with imaginary we can. So that I just represents that there was a negative under the square root. Okay, so that's 4, those are pretty much the main concepts in 4, which would be simplifying and then solving. Another area that I would say students struggle with is just remembering how to graph. So the different parts for graphing of 4-1. So I'll put a problem up here. And really it's not so much the graphing part as it is finding the little small parts. A lot of students, when they worked on their review, their study guide review, that first problem where it had you finding the y-intercept and all those things, took you guys about 20 minutes because you couldn't remember how to do that. So it's going to be really important to remember. So I'll write the section I'm going to do over. I'm actually going to pull this question from section 4.2, but it's the same idea. We're just going to be solving it. Solve by graphing. So if I give you the equation y equals, I'm pulling this straight from your workbook, x squared minus 6x plus 5. And so I'd be asking you to solve by graphing. And so I'm asking you for a couple of different parts. For part A, what I want to know is I want to know the y-intercept. So let's write that down. First, I want to know the y-intercept. And the y-intercept, no matter what equation I give you, the y-intercept is always when you take x and you plug into 0. So my y-intercept is going to be 0 squared minus 6 times 0 plus 5. So when we do that, 0 squared is 0, minus 6 times 0 is 0. So all I'm left with is 5. So the y-intercept, it's a point, would be the point 0, comma 5. That's my y-intercept. The next part they ask you for is usually the axes of symmetry. So your axes of symmetry would be negative b over 2a. So in our case, we have a negative from our formula, but we also have a negative b. So I'm putting in a negative 6 all over 2 times 1. So I would get positive 6 on the top divided by 2. So my axis of symmetry is 3. Now the next thing they ask you for is then to find, well, what's the x coordinate of the vertex? Or let's just say, let's find the vertex. Well, right now what you have when you found the axis of symmetry, you have the x of the vertex. So you have 3. You need the y. So to find the y, what you would do is take your 3, and I'll do it right under, and we're going to take the 3 and plug it into our formula. So the y would be equal to, all I'm going to do is plug it into our formula, 3 squared minus 6 times 3 plus 5. So 3 squared would be 9 minus 18 plus 5. And when we do that, that's going to give me the y of my vertex, right? So we would get negative 4 would be my vertex. So 3, negative 4 would be my vertex. I've been seeing students, what they do is they find the axis of symmetry, and then they say, oh yeah, I found the axis of symmetry. So the point is 3, 0 for the vertex. That is wrong. Do not do that. Okay, whenever you put a point together, what you're telling me is you took the x, you plugged it in, and that's how you got the second number. That's not a true statement, and those numbers should not be paired together. So we have the y-intercept, the axis of symmetry, and the vertex. So those parts, now that I have all those parts, I can start graphing, but I probably need to create a table of values. So that's usually the next thing that they ask you for. So we'll create a table of values. So I'm going to take my vertex and place that in the middle. I'm actually going to give us a little bit more values. So let's go ahead and put my vertex, as we know it's going to be the middle of our parabola, in the middle of our table. And then I'll pick some numbers below. So I'll say 2 and 1, and I'll pick some numbers above. And then all you would do is take those numbers and plug them into your formulas to find the y values. Okay, so when I do that, I'm going to go ahead and do that real quick. So when I plug in a 1, I get 0. When I plug in a 2, I get -3. When I plug in a 4, I'm working them out little by little. When I plug in a 4, I get -3, and then when I plug in a 5, I get 0. So I would go ahead and take those points and plot them. Now, I'm not going to graph them. You guys can graph those on your own. However, the problem said solve by graphing. So I can already solve this using the table because we know that the solutions to a graph are when it crosses the x-axis. So when y is 0, that would be our solution. So I don't even have to graph this to know the answer because these are the points where y is 0. So your solution for this problem would be, we have 1, 0 and 5, 0. So I don't even have to graph to know those are my answers. Okay? So you can text your question if you have any questions. This essentially covered, this problem just covered 4-1 and 4-2. So if you have questions, text them to, I'll put it up here again, or right there, that number. There it is. I will keep going though, so as we're going, you can text your question, then I will pause and answer your question. I'm gonna go, since we just did 4-2, I'm gonna do a 4-3 problem, which is just a factoring problem. So a 4-3 problem, let me write 4-3 up here. This is factoring. Perfect, I was just gonna do a factoring one. So this is factoring, and then I just got a question that has to do factoring, so I'll go ahead and do that. It was 10x squared is equal to 9x. So we're going to start this with factoring. Okay, we'll see, first of all, we'll try it, see if it's factorable. If it's not factorable, maybe we can do a different method. So if I have 10x squared is equal to 9x, and if I'm doing the method of factoring, in order to factor, it has to be equal to 0. So I can't even start this problem until I move my 9x to the other side. I'm going to say minus 9x. So then I have 10x squared minus 9x is equal to 0. So this is looking like it may not be factorable, but we'll try it. The first thing I want to do before I even start this problem, and before I start my box for factorings, I need to ask myself the question, is there a greatest common factor? So if I'm looking at the actual numbers, 10 and 9, well, the answer would be no, because 10 and 9 have nothing in common. But if I look at their variables, 10x squared and 9x, they do have something in common. So I can first start this problem by pulling out an x. So I would be left with 10x minus 9 equals 0. And so I've actually already done the factoring. There's nothing left for me to factor. So for solving this, I would set up both of my factors that I have here equal to 0. So then I would say that x is equal to 0. That would be one of my factors. And then I would say that 10x minus 9 is equal to 0. So I would have to solve this. So to solve this, I would add 9 to both sides and then divide by 10. So x would be equal to 9 over 10. Okay, so we didn't even have to use the box or the x with this problem because it was a problem that had a GCF. Yeah, I'll go through another one that has a, maybe we can use a box so you guys can kind of see that. Let me try to find one that, okay, we'll do this one. 3x to the second power minus 13x minus 10 is equal to 0. So we're trying to find the solutions here. The method that I have taught you in class is the box and the x. Now, you may know another method for factoring, and that is totally fine. That is just on your test, just make sure you show your work so I know how it is that you're getting your answers. You don't have to use my method. If you know another method to factor, you're more than welcome to use that method as long as you're showing your work. So to factor this using the box and the x method, this is different from our completing the square box. My first step would be to go ahead and take my first term and put it in my first box. So my first term in my first box. And actually, before I even started this box, I should have asked myself the question, do my 3 terms have anything in common? If they don't, then I can start the box. Okay, so I started the box and I saw right away it had nothing in common. And then in my last box goes my last term, and it should be a negative term. Okay, so once I have those two situated, I'm going to draw my x. On the top of my x, I would multiply these guys. So my first and my last term. So here are my guys. That's what's going to go on the top of my x. So I would get negative, and I keep forgetting to write that negative 30x squared. And then on the bottom of my x goes my middle term. So negative 13x. So now we're asking ourselves a question, well, what numbers multiply to give me negative 30x squared? And those same exact two numbers are going to give me negative 13. Well, a lot of times, the first ones that literally just popped into my mind just by looking at this was 10 and 3. Well, 10 times 3 does give me 30. However, if I were to say I need a negative 30, so I know that either 10 or 3 has to be negative in order for me when I multiply to get a negative 30. But 10 minus 3 gives me 7. So the 3 can't be negative. And if I make the 10 negative, negative 10 plus 3, that also doesn't work. That would give me negative 7. So I can't use that. But I can use 2x and negative 15x. So 2 times negative 15 gives me negative 30. And 2 minus 15 gives me negative 13. So those are our missing guys in our boxes. And they can go anywhere you want in any of these boxes, any of the missing ones. Okay, so we've done probably the hardest part of the process is filling in the box. The last part of this box is just finding the outside. So a couple of different ways that you can look at this. So you can look at the box by saying what two numbers multiply to give me 3x squared. So I can say x here and then 3x here. So x times 3x multiplies and gives me my box of 3x squared. But then I have to say, well, 3x times what gives me a negative 15? Well, negative 5. So I'm giving you just a different way to think about it. And then I would find my last guy here in this spot here. I'm looking for x times what is going to give me a 2x. Well, x times 2 gives me 2x, and there would be the outside. The other way to think about it is you look at your boxes and then find the GCFs. So 3x squared and 2x, they have a greatest common factor of x. Negative 15x and negative 10 have a greatest common factor of negative 5. And these two have a greatest common factor of 3x, and then our back ones have a greatest factor of 2. Okay, so that's another way. So we have found the factors. our factors are 3x plus 2 and x minus 5 is equal to 0. Now, if I were just to ask you to factor, you'd be done right there. But the problem is asking you to solve. So you have to set each of your factors equal to 0, equal this to 0, in order to solve. Okay, so my first one, I'm going to minus 2 and then divide by 3. So I would get x is equal to negative 2 divided by 3. And then my next one, I would add 5 to both sides. So I would get x is equal to 5. And those would be my solution for this problem. Okay, so that's a brief overview of 4-3. All of the problems in 4-3 are asking you to solve specifically by factoring. So this is one of the methods we learned. We also learned how to solve by graphing, by factoring. The other one was, I'll go over that one next, is completing the square. And that was 4-5. If you have any questions, feel free. You can text me. If not, I'm just going to keep on going through our sections. So 4-5 was completing the square. And completing the square is kind of like factoring. We're also going to use a box. It's just the box is a little bit different, meaning what we put inside is different. So let me pull up one from completing the square. I'm going to pull it from your workbook. I'm going to try to find one that might be a little tricky. Okay, so we will do 2x squared plus 8x minus 3 equals 0. So we're also going to solve this, but now we're solving just with a different method. You could, if you wanted to, and if it was factorable, you could try to solve this by factoring. If I didn't specify, however, I am specifying I want to do this with completing the square. You could also try to do this with quadratic formula. So if I don't specify, you can use whatever method you want. I'm specifically going to use the completing the square. To use completing the square, the first thing, right, is we're going to move our constant. So instead of having minus 3, I'm going to move that to the other side. So I'll go ahead and move them. Then my new problem would be 2x squared plus 8x. Remember, with completing the square, we're going to be adding a number. So I'm just going to go ahead and put that line there. Is equal to 3. Now, I could jump straight into my completing the square, but we have another problem. We have this 2. And when we're completing the square, we can't have any number in front of the x squared greater than 1. So essentially, there should be no number in front of x squared. So we're going to get rid of that 2, and we're going to get rid of it by dividing everybody by 2. So I got to keep this equation balanced, so I got to do it to everybody. So I am left with, when I divide everybody by 2, I have x squared plus 4x plus my number that I'm going to be looking for is equal to 3/2. And if you feel more comfortable, you can change that 3/2 to a decimal, and it would just be 1.5. So now that I have this, now I can jump to my completing the square box. So I'm going to do it on the side here, because completing the square box doesn't take too much room. So here's my box, and what I'm looking for is our missing number, what I'm going to be adding to my problem. So with completing the square box, your first term goes in the first box. Half of your b term goes in your diagonal, so half of 4 is 2x, half of 4x is 2x. And then in our last box, if you can't remember how to find that, the formula for that, all you would do is say 2 times 2, which would be 4. So that is our missing number. So I add 4. Now, the equations have to stay balanced. So if I add 4 to one side of the equation, I have to add 4 to the other side of the equation. Okay, gotta keep it balanced. So the purpose of completing the square is that I can rewrite it as a perfect square. So I'm going to find the outside of my box. So here's the outside of my box. And now the whole reason that I did the completing the square is so that I could rewrite this whole side in terms of the outside of my box. So instead of writing it as x squared plus 4x plus 4, I'm going to write it as x plus 2 to the second power is equal to, and now I'm going to add my 1.5 plus 4, so I get 4.5. So this here, getting it to this point is probably, I would say, the hardest part of the completing the square process. Once you have it there, what you're going to be doing is you're going to be solving. So to solve this, because we have a squared, I have to square root both sides. So when I square root, don't forget to give your plus or minus. So I'm left with x plus 2 on this side because the square root and the square cancel each other is equal to plus or minus the square root of 4.5. So I'm going to go ahead and take that square root now. Let's see, square root of 4.5. If I take the square root of 4.5, it's going to give me 2.121320344. That is way too long of a decimal. So I'm just going to leave it as a square root of 4.5. I'm not going to change it. I'm going to leave it just like that. Okay. So my last step then, if I'm going to leave it as a square root, I still need to get an answer. So I still need to get x by itself. So I'm going to minus 2 on both sides. So I would leave it as x is equal to negative 2 plus or minus the square root of 4.5. And I'm going to leave it just like that because I can't simplify the square root. Now, if I could simplify the square root, I would. But because when I plug in the square root of 4.5, I get a really nasty decimal, I'm going to leave it just like that. So that would be your final answer. Okay, so I got a question for Dewey quadratic formula. Let me see. So we could actually do the same exact problem that we just did by using quadratic formula. Now, we'll do a different one. Let's say I'm going to pull one straight from our packet. Our workbook, I'll do, this is from 4-6, and I'm doing number 22 on page 56. So that's where I'm getting this problem from. It is 12x to the second power minus x minus 6. And let me label this so that we know this is quadratic formula. Now, I'm actually going to go through this entire problem, which first asked us, which is going to be important, it first asked us for the discriminant. So I'm going to first do that. So part A asks us to find the discriminant. So your discriminant formula is b squared minus 4 times AC, and that's what comes from, and I'm going to write the quadratic formula here as well. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac, all of that over 2a. So our discriminant really comes from our quadratic formula, and all it is this bottom part here. So if you know the quadratic formula, you know the formula for the discriminant. So I'm going to find the discriminant first. So my b is -1, and actually let me define these variables as well. So I will say that a is equal to 12. That's the number in front of x squared. B is equal to -1, and then my c is equal to -6. And those all came straight from these numbers here. Okay, so now let me continue. It's and this should be a squared, minus 4 times a, which is 12, times -6. I'm going to find that. When I do that, and actually let's make sure I did that right. -1 squared is 1. -4 times 12 is 48. And then 48 times -6. So my final answer here would be 289. So what the discriminant tells me doesn't tell me the answer. What it tells me is if I have any real solution. So part B asked us to say, describe the number and type of roots. So I would have a real number, and because it's a positive and it is greater than 0, I would have 2 roots. Okay, and this is also found in your notes, this part that I'm doing here. Now, finally, part C is to find your answer. Well, because in part A we found the discriminant, we've actually found half of our quadratic formula. So now we're going to use the quadratic formula to find our answer. So I'm going to plug in, I have negative from my formula, and then my B is -1, plus or minus the square root of your discriminant. And we just found the discriminant, so that's what's going to go under my square root. I'm not going to do it twice. That's what goes under my square root. All of that over 2 times 12. I'm going to start simplifying. So negative times a -1 would just be +1, plus or minus. So we need to try to simplify our square root guy right here. So I'm going to, on the side, I'm going to try to simplify him. Okay, so I'm going to try to find some perfect squares that would break down our 289. Okay, so I'm going to see if I can find any numbers. So I'm going to start by starting with our first perfect square, which is 4. I'm going to divide the number by 4, and that doesn't work. So then I'm going to go ahead and say our next perfect square, so 4, then I'll say 9. That doesn't work. So I got another question, but let me finish this one and I'll answer that question that I just got in. So then I say 289. Doesn't look like there's any perfect square that breaks down 289. Let's see if there's any other numbers that break down 289. Nope. So it looks like 289 is a prime number. Now, if I notice how I did go through the motions, though I did try to simplify that 289. You should also try to simplify before you just dismiss it and say, oh, I can't do anything with it. Try to simplify it by breaking it down in perfect squares. So here is I'm going to leave it as 289. And then 2 times 12 is 24. And I can't simplify anything else here. So this would be my final answer. Right? I really have 2 answers. I have 1 plus 289 over 24, and then I have 1 minus 289 over 24 because of our sign of plus and minus. And the question I just got, let me answer that one. So let's see if I can understand the question. So if you just asked me this question, I'm answering it. So let's make sure, I'm going to put this up here. So it says, if you have a box and there's a -5, so let me draw my box, make sure I have it right. I'm just going to make up a box. Okay, let's say we have x squared here. And they said, okay, if I have a -5x and then a 25 here, that's what I'm assuming. Okay, so then if you would take out a -5 or a +5. So it depends on what you have. So you would look at your numbers. So let's say I'm going to try to make up a number here. Make this one a +5x. And then that would have to be -25. I'm trying to see. Okay, let's make it a negative. We'll make them both -5s. So the way you're trying to figure this out is you're asking yourself, because the way that you get 25 is you're saying x, and then times this -5 is going to give you that -5x. So this guy here would have to be a -5, even though they're both not negative. It has to be a -5 because x times -5 gives me -5x. Then let's say I'm going to finish this box up. Over here, I have another -5. I'm going to pull that out. Now I'm going to test it. So this number here, -5, and this -5 here, when I multiply, have to give me a positive 25. And since -5 times -5 do give me 25, then those signs work. I hope that answered your question. So you guys are texting me and I have no idea who it is. All I see is some random number. So I have no idea who I'm talking to. Okay, so I hope that answered your question. If it doesn't, you can continue to text me and then I will try to continue going with that one. So I've gone over essentially 4, 2, and 4, 1, and 4, 3, 4, 4, 4, 5, 4, 6. The last section we learned, and that was today or yesterday and today, was 4, 7. And it seemed like a lot of students understood this. They really got this, which was good. So the transformations. So I'll go over, there's probably 3 types of questions I can go over in this section. The first type of question for 4, 7 is listing the transformation. So I would say 1/4, let's just say, make it a negative. X minus 2 squared, let's say plus 7. And I could ask you, the first type of question that I could ask you that comes from 4, 7 is simply just to tell me what are the transformations. So if it's a negative, that negative, you guys already know what that negative does. All that negative does, it flips the graph down so that it's frowning. So I would say down because of the negative. And then I look at my A value. The A value tells me if I'm stretching my graph or if I'm compressing my graph. If the A value is a number that's less than 1, but greater than 0, so 1/4, if you don't know that off the top of your head what that is, if it's a number greater than 0, you can divide it. And when you divide that, 1 divided by 4 gives you 0.25. 0.25, that's a greater than 0, but it's less than 1. So that means my graph is compressed. So I would say compressed. Then I would look at my -2. Well, it's with the x, and we know that the x-axis moves our graph left or right. Remember, though, your brain wants to think because it's negative, we're moving it to the left, but it's actually opposite. If it's a negative, we're moving it to the right, 2 units. And then our last number, this one makes sense. This has to do with our y value. So our last number, we're moving it up 7. So just be up 7 units. Okay, so that's the first type of question that you could see tested about 4, 7. That's a good question. So could I always use a vertex form to solve? Yes, you could. You could always use a vertex to solve, or would it take longer to transfer the quadratic? It kind of really just depends. You can always use a vertex form to solve. Yes, you can. I hope that answers that question. And that's what I'm going to do next, actually, is transferring it over from a standard to a vertex form. So let's say I give you a question like this, and I ask you, this is in standard form. This is the form you guys have all been used to, and I ask you, okay, I don't want it like that because I like vertex form better. I want it to be in vertex form. So you can change it to vertex form, and it's not too bad to change it to vertex form. Change it to vertex form, you're going to complete the square. And I think this completing square is just a little bit easier. It's not too bad. I'm going to group my x squared term and my x term. And just like before, I need to add something to these guys in order for me to complete the square. But the 2 doesn't go anywhere. I still need him. Don't forget about him. So if I were solving by completing the square, I'd be moving the 2 to the other side, but I'm not solving. Okay, so I'm going to draw my box. Since it's completing the square, I don't really need too much space. First term goes in my first box. Half of my middle term, so half of 6 would be 3x. And then my last box, if you can't remember the formula, is just 3 times 3, which is 9. So 9 is our missing number. Now, because I am leaving the 2 on the same side, I'm not going to be adding 9 again. I'm going to be subtracting 9 because 9 minus 9 is 0. So I really just added 0 to this equation. I really haven't changed it. So this whole thing, the reason to complete the square is so that I can write it in terms of the outside of my box. So here's the outside of my box. Right? And here's how I would write this. Instead of writing it like that, I'm going to write it in terms of the outside of my box. That's the point of completing the square. So we can rewrite it. And then 2 plus 2 minus 9 gives me a negative 7. And there it is in vertex form. Now I could ask you a couple of questions now that it's in this form. I could have asked you when they were in standard form as well. But I'll ask you now that they're in vertex form. I could ask you, well, what's the vertex? Well, the vertex would just be our h and our k. This is our h, this is our k. Now just remember that you take, this is our h and this is our k. Remember, you take the opposite of h, so it's going to be negative 3, comma, negative 7. There's my vertex. My axis of symmetry then is the same as the x value of my vertex. So it's x is equal to negative 3. What else could I ask you? I could ask you for vertex. I could ask you for axis of symmetry. I could ask you to graph that. I could ask for the y-intercept. So let's say I ask you for the y-intercept and it's in that form. The y-intercept never changes. The y-intercept is always 1. I plug in a 0 for x. I'm plugging in a 0 for x, okay, into my formula. So 0 plus 3 is 3. Then I have it squared minus 7. 3 squared minus 7, this would be a 9 minus 7, so I would get 2. So my y-intercept, it's a point, would be the point. I plugged in a 0 for x, and when I did that, I got a 2 out. So that would be my y-intercept. Right. I'm going to ask you to graph this. You would need a couple or more points, so you can make a table, pick some values for x's, plug them into your equation, and then plot those points, and that would be your table. I could also ask you, is this a max or a min value based off the formula? Well, if we're looking in the front here, there's no actual number, but there is an imaginary 1 there, and it's positive because there's no negative sign, so therefore it means my graph is smiling, he is happy, yay. So we have a minimum value for this parabola. I'll put the vertex there. Now I could ask you, what's the value of that vertex? Well, we already found that. It's negative 3, negative 7. I could also ask you for the domain and the range. So the domain is always going to be the same, and I'll put this over here, I'll squeeze it in. It's always all real numbers, so from negative infinity, that's my below. It's really not that scary, I promise. He just sounds like he is. Okay, and then your range is, we're looking, I like the picture for the range. So what I'm looking for is numbers that are bigger than my vertex and the y value of my vertex, because range has to do with y. So I would write this as y is greater than or equal to negative 7, since that was the y of my vertex. Right? So that's really pretty much it. It's 7:26. You can definitely, I'll stop talking. You can ask me questions, any last minute questions that you may have. Feel free to text me, but I am going to stop talking now. So I may have assigned number 14. If I did, I am sorry if I assigned number 14 on page 58. I can go over that, but I did not mean to assign that to you. I thought I had taken that off of yours. So I may have assigned number 14. Oh my God, I'm talking to myself. Okay, here we go. But I will show you if you're wondering how to do number 14. I can go over that. So this is number 14 from page 58, which was 4-7. And they're asking you to write an equation for a parabola with a vertex at -3, that passes through 318. So in order to do that, we need to know the vertex formula. So here it is, and this is formulas. This is the one I gave you today. So they give me the vertex. They said the vertex is at -3, they said. So that means I know my h and my k. So that's my first step. I'm going to replace my h and my k. So I'm going to rewrite this equation. Y is equal to a x. Now, remember that when I'm plugging in my h into my formula, if it's in the vertex, when I plug it into my formula, it's opposite. So I'm going to plug it in. It's going to actually be a +3. Close that. And then I have my k is +0. So I really don't need to write that because +0 is not going to do anything to my formula. Adding nothing is not going to do anything. Now, they also gave me a point. They gave me the point 3,18. So if they're giving me that point, they're actually giving me an x and a y as well, because we need to solve for this a. We got to get that a in our formula. And I don't have any other way to do it except for solving for it. But they gave me an x and they gave me a y. So again, I'm going to rewrite this formula, but now I'm going to plug in my x and my y. Well, my y is 18. I have no idea what my a is, so I'm going to leave them blank. And then my x, we just said was 3, plus the 3 from my vertex. And we're going to square that. And we're trying to solve for a. Okay, so I would get 18 is equal to a. 3 plus 3 would be 9 squared. So I get 18 is equal to a, and then a 9 squared is 81. I'm almost done here for solving for a. I'm just going to divide both sides by 81. So I get that a is equal to 18/81, and I can simplify that. I'm going to divide both of 18 and 81 by 9. So on the top, I get 2/9. So then my final answer would be y is equal to my a value, which is 2/9, x plus 3 squared. And that would be your final answer for number 14. You don't have to add the 0 since it's 0 is nothing. So I don't have to put the k value. Okay, so we went through all these steps right here to simply find the a value. And once I found the a value, I could rewrite it in vertex form. Okay, so this would be our final answer. Okay, so that is it. I am done for tonight. I hope this was helpful. I wish you guys luck on your test. I will see you tomorrow and Friday. Have a fantastic night.